Today I've got an SD card in for data recovery that's been bent. Go on, focus. Let's take a look. Check this out. She's definitely cracked. Let's see what it's like inside. Got him out okay. Don't know what this liquid stuff is. It's definitely bent. Doesn't look too bad. There's a little bow in the PCB, but I need to take a close look under microscope. This wiggling is a bit weird. Maybe someone's had it open before. I'm going to check all the wiring, the trace wires, make sure everything's okay and connected. There is a bit of a line here where it has been bent. I'll clean it back and I'll inspect it a bit further. Once you clean it, it does seem okay. Just checking this little crack here. If it's just on the surface, it'll be okay. Because this doesn't detect at all in a card reader, I'm going to hook it up to this special device so we can interact with it more of a lower level. See what happens. We'll see what it has to say for itself. So I'm just going to hard solder the power and negative wire, and then there's 4 wires for the data bus and a command wire, clock wire for the secure digital protocol. So I'll hook all them up. Okay, this is my solder board. I've got it all probed up, so let's hook it up and talk to it. Now to get this to work, I need to put the capacity in, and usually I like to read that from the label on the SD card itself. But if you notice at the start, the label has been removed and not given it to me, so I actually don't know what size it is. So I just have to set my pins up that I'm using. It's pretty simple for the secure digital protocol, the SD. It's 4 data pins, so we've got 0, 1, 2 and 3 set up. We've got a command pin, this is what issues all the commands, and we've got a clock. Clocks in computers are like drummers in a band, they keep the time. Let's run a quick test of the pinouts. Make sure everything is working okay. Okay, that looks good, so we can set that. So now we just need to initialize the controller. We'll see if we can talk to it. So initialization. Alright, here goes nothing. So we're going to try and talk to the chip. We do. What have we got here? We've got some information. So there's some standard commands that the SD protocol uses. Can I make this bigger? Yes, I can. And let's have a look. Okay. So you can see here we've got a response from the controller chip, and we have manufacturer ID hex 1. We've got a product serial number here. We've also got a manufacture date for September 2009. We got a name SP08G, so 8 gigabytes. I think we got it correct. So the LBA size is 7741,440 with the command 9. Let's check that. We also can't read the memory. If I click this play button, no I can't. It's all black sectors. I'll go out and click this play button and show you. It looks like it's not reading. No, it's not reading anything. So it can't talk to the memory. And remember when I was looking at it, I wasn't sure. It seemed to be a bit squishy, like maybe someone's removed it before, or maybe the little PCB has broken underneath it. We definitely cannot access the memory. So I've got to make a decision now what to do. Do I take the chip off, or do I try and repair the little PCB? Let me have a think. The other thing I want to show you is this manufacturer ID. We've got hex 1. I've been collecting these over the years, and I believe this is possibly a Panasonic SD card. To get my correct chip adapter, it is a 14 by 18 millimeter one. So I shall set it up correctly. And she pops, and let's see if we can get an ID from this chip. With the chip in the reader, let's see if we can get the chip to ID. If we get a successful chip ID, it'll tell us exactly the size of it. Or the chip could be the problem here. The chip may be faulty. It could be damaged. It looks okay under microscope. We're not getting anything here. Let me just check on things. There we go. Okay, I've got the chip to ID successfully this time. Let's see what it is. I just had to check the position of it in the reader. It was a little bit off. What does this say? Let's go direct. That'll do. So you just see here we've got the chip detecting as 4 gigabytes from the chip reader. And if we go to Google, I've had a look. If I put the Panasonic SD in, and I've also added this code here, which is the controller chip, the main little chip on the SD, and it's come up with this. This is probably what it used to look like. Just want to do some research. While I had the memory chip removed from the SD card, I wanted to reinitialize the controller and see what data it output. And it is a bit fascinating because the manufacturer's ID and the OEM application ID is the same as when we read it with the chip on. But now that the chip is off, it's missing the product name. It's got null entry for the revision. The serial number is null. This is null for the manufacturer's date, and the max LBA has also increased. Maybe that says 8 gig if I did the maths, not sure. This makes me think that maybe this information is stored on the NAND chip. So the controller has to get this from the NAND chip. So I have hit a bit of a problem with the memory dump from this memory chip. I've been going through it, and there's a couple of issues that's stopping me from seeing the data. If you think that you can just read a memory chip and see all the data, you'd be wrong. What these vendors do, what the manufacturers do, is modern controllers for the last 10 years have been using an exclusive OR algorithm. And the reason why they do this is they want to scramble the data throughout the memory chip. This is because these memory chips are so cheap that they don't last long. And if the data is maintained in one position, it will wear out. It will wear out in one section, and the device will fail. So they use this exclusive OR algorithm to distribute the data throughout the memory chip. And they're very difficult to reverse engineer. Unless it's been solved before, it's very difficult. And this is the case with practically all NAND memory chips, whether they're on a USB stick or an SD card. Now, I've been going through this one, and it appears to me that it's using an even more complex exclusive OR pattern, known as dynamic exclusive OR. This algorithm changes I like to pronounce exclusive OR as XOR, so it's just easier for me to say. So this XOR algorithm key changes each time there's a write to this memory card. It's also got ECC scattered throughout the memory. Again, they need a lot of ECC because these memory chips are so bad. They fail behind the scenes. They don't last long. And the ECC, I'm not sure what the structure is for the ECC for this chip either. So I have hit a wall. I'm trying to think what to do next. I might go back to the physical card and look at that. Just back with the PCB on the microscope. Look, I'm not happy with this data 0 and data 1 trace line, so I am going to repair it with a bit of solder. So what I'm going to do is fix all these little broken wire traces by soldering them back together. I need to scratch back the top layer of the wires, and I'm just going to do that with this scalpel. Just take my time. You don't want to damage or make the gap too big. You want to try and keep the gap as close as possible that you're soldering, so solder can stick. If you break it apart too much, the solder won't ball and join each other. So I have to be very careful. I want to remove just enough there we go, there's one ready. You can't even see that with the video I'm filming. Does that do anything else? No, not really. Let's try and just get a better focus. Oh, you won't really be able to see it. Microscope would have been better for you guys, but it's annoying for me. Those two are done. They're data lines. No wonder it wasn't talking. We did have something here. It's hard to tell. So in this section here, on the microscope, even on the microscope, it's hard to tell. There's definitely a crack there. And I think I might... should I try? Where is it? It's on the back. I can always come back. I think I might leave this one and come back to it. It'll be easy to get back to it. The chip side's going to be a bit harder. While I got the chip off, I've got a little bit better access to these little trace points. What were we looking at again? Same thing here. I think we might be alright on this side. It's just going to be harder to do once it chips back on, so I've really got to make a good call on this. Let's have another look. There's a crack on up here. Even on the microscope, I can't really tell if it's cracked enough to stop the connection. The original chip, I might just see how much room I got. So if I put the chip back on, maybe about here, how much room do I have? Yeah, there's a little bit of room. I think we might... I don't know what to do. Microscope can't tell me. These ones are really fine, so if I solder them, I run the risk of getting solder and shorting each other line out. If I can avoid it, I will. I think I'll be right. Let's put the chip back on. I just got to get the correct orientation and give it a clean. Okay, I forgot. I'm not going to put the chip back on. I'm going to resolder these two pins back first. So I've given it a bit of a clean. I'm going to put some flux in there. Where's my solder? I'm going to start with the outside one first. It's a bit harder to get to, so just... And I might have to change my tip, my soldering iron tip. Okay, I think I joined them. Can I get that one as well? I can't see. Alright, let's see if I got it. It does look like I've soldered them together, but it's so tiny that even on under my microscope I can't pick it up. I'm going to do a beep test by touching the pin at the top and following it to the other side. Looks like we got it. Let's do it with this other pin. I believe this is pin 7, another data line. Okay, I think the solder we've fixed it with the soldering. Now let's put the chip back on. I've reballed the chip so it's ready to be soldered on with the hot air. So I've initialized the memory card again with the chip soldered back on, and we're kind of back to where we were. So we've got all the ID happening again with the serial number, manufacturing dates all come back. So that must be stored on the memory chip, but we still don't have access to the data. So it's possible that those other lines are damaged. So we'll have to go back to the soldering and get access to the rest of these lines. I've decided I'm not going to bother repairing the little trace wires. Instead, I've followed down the wire themselves and I've found little vias. Vias are holes that connect a trace wire, go through to the other side. If you have a look here, I've soldered them over a bit. That makes it easier for me to actually connect the probes to it. I can also test the pins, and I'm going to have to write down which little via is what pin now. But I can at least test them all. So this would be pin 9, and it connects there. All good. The clock I'm not touching. That's a ground. We got data 0. Data 0, hello. Data 0 is not good. Alright, let's go to, I think this is data 1. What's going wrong here? We're not really. That doesn't feel good at all. Maybe our little solder joints are broken. It's kind of okay there. So we'll have to write these all down. These will be better to interact with now anyway. It's good there, but I'm not getting anything here. Okay, I think this will be better to interact with these vias anyway. So I'll hook the probes up and let's see what happens. I just got to write them all down. Now with all the pins connected to the vias instead of the SD card pins, let's initialize and see what happens. Looks like it's configured all okay because we're getting all the same ID numbers, but we're still failing to read this card. I'm just going to wait for the software to finish doing what it's doing. Okay, so we still can't read any sectors, but we're getting the same ID format. Even though I've changed the pins around, we're still getting the same ID format, but we can't read anything from this card. Where to go now? I don't have one, but I'm probably going to need to get a new controller chip and replace the controller chip. I'm not sure if I'm going to get success on this. In fact, I think I would reverse engineer the PCB, manufacture a PCB, get a controller chip and rebuild it. I can either go that direction. I could find someone who has reverse engineered the exclusive OR algorithms and the ECC for this controller. There's a few different directions I'm going to have to go, but I will have to wrap up this video because I can't think of what I can do immediately today without going into more engineering with this. Anyway, I'll have one last look at it. If you're new to the channel, welcome along. I do data recovery and I upload regular videos. Hope to see you again soon.